the review that was in, it's just the practice review. Let's see. Let's see if I can just upload it in here. Alright, so this is what I was planning on going through, but I'm more than happy to take questions that you have also that you want to go through individually as well. So let's start off with any questions that you might have that you wanted to look at, and then we can start in on this little practice.
Kathleen Baker, a woman whose teachings served later to form the very foundations of religion, and according to the same...
I had a question on the Module 3 study guide. It was... Do you want me to read it to you?
Just 1 second. Let me take that up. Make sure I have my chat and stuff up here. Okay, yeah, so I'll just work this over kind of on the side here. What is the one that you would like to go over?
It's a compound inequality, and it is -2 is less than -1/2 x minus 5.
For some reason my pen is not working. Let me unplug my tablet and plug it back in again. Okay, read that to me again.
It is -2 is less than -1/2 x minus 5 is less than 1.
Okay, it's frozen up again. Okay, -1/2 x. Sorry, minus 5, is that what you said?
Yes. Yes.
Is less than
1.
Okay.
1.
All right, so we're trying to get x by itself in the middle, right, on this. So the first thing that you'd want to do is add 5 to all 3 parts. And then if you guys can mute yourself except when we're talking, that will help with the background noise and stuff. All right, so then we get 3 is less than -1/2 x, which is less than 6. And then on this next part, right, in order to get rid of that -1/2 times x, we'd want to multiply by its reciprocal, which is going to be, we're going to be multiplying by -2 on all 3 parts. And remember, if we're multiplying or dividing by a negative number, that means that we need to flip the inequality signs. So on this one, we're going to have to flip both of those signs. So we'd have -6 is greater than x, which is greater than -12. And then how does it ask for the answer to be written?
It says it wants it in interval notation.
Okay, and so when you're looking at this, right, on a number line, right, so we have x is greater than negative 12, right, so that's going to be here and to the right, and then x is less than negative 6, so that's here and to the left, so it's going to be the stuff in between. And so when I write it in interval notation, you need to make sure that you're writing it from smallest to biggest. So we'll have an open, like a parenthesis there, since it's an open circle, negative 12 to negative 6, and then parenthesis. Is that what you did, or?
I did negative 12 to infinity because I thought it was whenever you switch the inequality. I was just confused on that. I thought it turned it into like a greater than problem.
Okay. Yeah, I know it's going to flip both of the signs. So if we kind of read these separately, right? X is greater than negative 12. Or we could read this other one as, and we kind of have to read this one backwards, x is less than negative 6. Does that make more sense?
Yes, it does.
Okay.
Yes, it does.
You're so welcome.
Thank you.
Okay, anything else on stuff that you guys wanted to look at specifically before we go on to this?
I was hoping maybe we could do on augmented matrix for a problem with infinite solutions. So like putting it in parameters of z.
Sure. Yeah, we can do one of those. Let's see. Those ones aren't going to be that way. But maybe when we do the matrix problem down here, let's do one just regular, and then we can go through and do one that is, you know, the infinite solutions. I'll write that here next to it.
Okay, thank you.
And then we can do one of those, the infinite solutions too. Okay. All right. Well, anything else that you guys are dying to make sure that we go through today? Uh-oh.
I just got off, I don't know if someone already said this, but solving equations with 3 variables.
Yeah. So we can, so something like this, number 6. Yeah. So not with the matrix, just solving it without the matrix, right? Okay.
Yes,
yeah,
exactly.
We can do that. We'll be doing one of those tonight. All right, mixed solutions problem, and that's actually one that we're going to start right off with. We have this. You guys can still hear me okay, right?
Yes, I can.
Okay.
Yeah, I can hear you.
For some reason, it's doing something weird on my end on the WebEx. So I just make sure, like, if there's some kind of weird thing, just send me something in the chat so I know that if there's something weird going on there. Okay. All right, well, let's start through these, and then probably as we're going through some, it might jog your memory of other things that you want to make sure that we go through and stuff like that. So let's just kind of start here. So on this one, right, we're taking and we're trying to mix 2 different types of solutions together. Right? We have a 51% solution. Right? And we also have a 66% solution. And we want to end up with a 55% solution. Right? And it also tells us that we want to end up with 150 milliliters. Right? So those are kind of the important information that we need to pick out of this. So I like to set these up as a little chart to help organize the information. It's up to you if you think that helps you or not. But when you do this, it's good to keep in mind that the things that you're mixing together is what we're going to be putting along the top. And along the side are the things that have labels or units, right? So you're kind of looking at those type of things. So let's set up a little chart here so you can see what I mean. So the things that we're going to be mixing together on this are which percents? Which two are we mixing together?
The 51 and the 66. The 51 and the 66.
Okay, so I've got the 51% solution mixed with the 66% solution, and we want to end up with a total, and I'm going to put that there so we know that's what we're trying to end up with, is a 55% solution. And then when I'm looking over here at the units and labels that I'm talking about, we've got these milliliters, and we also are dealing with percent. So those are kind of the labels that I see that I have that I'm going to be dealing with. So I'm going to put milliliters here and percent here, and then also the total. All right. So I always like to make sure that I'm assigning variables and making sure that I know what I mean by each one. So I'm going to call X on this the milliliters of the 51% solution. And my Y, I'm going to call the number of milliliters of the 66% solution. Right? Because those are the two things that I'm trying to figure out, right? How much of each must be mixed, right? So that's why I'm calling each of these X and Y. So I don't know how many milliliters of the 51% solution I need, but I'm calling it X. I don't know how much of the 66% solution I need, so I'm calling it Y. But I do know that my total amount of milliliters, right, needs to be 150. Right? And so when these two are added together, they must add up to be 150. And I don't know if that's going to be, one of them's going to be 100 and one's going to be 50, or if they're both going to be 75, or if one's going to be 20 and the other one's 130, right? There's a lot of different combinations that I can come up with for, what plus what is 150. But I'm going to write that over here as my first equation, because I have one equation already made. Right, then in this second row, I guess it's really the third row down on this chart, but in this next row where it says percent, I'm actually just going to take my percents and I'm changing those to decimals, right? So remember, when I'm changing a percent to a decimal, I'm just moving that decimal point back 2 places. So that's going to be 0.51, 66% is 0.66, and 55% is 0.55, right? And so that's just to kind of help me remember and kind of change, to change those percents to decimals. And then to get my other equation, I'm just multiplying the 2 rows together, right? So when I multiply X by 0.51, I get 0.51X. So I don't know how many milliliters of this solution I need, but I know it needs to be a 51% solution, right? The other one, 0.66 times Y. And then this is the part that most students forget when we're doing this, is that you've got to multiply those numbers together as well. So what's 150 times 0.55? Anybody? Just multiply those two together. Yeah. And some people put in the chat 82.5. All right, and so then this last row is going to make my next equation, right? So when I have two equations, I need to have, or two variables, I need to have two equations to be able to solve this. So my other equation is going to be 0.51x plus 0.66y equals 82.5. Okay. And now I've got my two equations, and now I can solve this, right? And you can pick, it doesn't matter, it's not going to say on the test anywhere that you have to solve this a certain way. So you can decide from here whether you want to solve it by substitution or by elimination, right? And both ways work. Anybody have a strong opinion on how you want to solve it? Okay.
I prefer substitution. I prefer substitution.
Awesome.
Yeah, I was going to say
Let's do
that.
substitution. All right, so in order to do substitution, then I need to get one of my variables by itself. So I'm really going to rewrite this top equation because it's going to be easiest to get one of those variables by itself there. So if I try to get x by itself, that means I'm subtracting y over, right? So my new equation would be x equals 150 minus y. Right, but you could have done the same thing. You could have solved for y and got 150 minus x. It doesn't matter. Right, both ways will work. And then go ahead and let's substitute that in now, right, in place of our x. Okay, so when I put that in, I've got 0.51 times 150 minus y plus 0.66y equals 82.5. Okay, so I want you guys to try and just take a couple minutes and solve this the rest of the way down for y. See what you come up with for y here.
I got that y equals 40.
I got that y equals
Okay.
40.
So let's see. It looks like some people are saying that's what they got there too. Just another minute, make sure everybody. I'm running out of room here, but hopefully when you look here, you can see what I came up with and make sure you came up with the same thing there. All right, so 40 what? So if you came up with 40, make sure you don't just stop there. All right, you've got to put your label on it and make sure. So 40 what? What did we find? Okay, 40 milliliters of which solution? Well, we said Y was our 66% solution. So you got to be really specific and make sure you know which one's which. And again, that's I like to assign these variables right off the bat so you remember what that is. So 40 milliliters of the 66% solution. All right? And then can somebody tell us how would you go about figuring out what X is?
Subtract it from 150.
Yeah,
Subtract it from
so go back to
150.
that top equation here, right? And we knew that together they had to add up to be 150. So really, right, you're just doing like 150 minus 40. Or, you know, some people are just like, we'll put that Y back in there. X plus 40 equals 150. So we subtract that 40 over to figure out what X is. Right, so we get 110 milliliters of the 51% solution. Right, so again, make sure that you're very specific. You know, like on the, on the test, there's going to be different blanks to put in your answers. And so you just want to make sure that you don't mix those two up. I see that happen so often where students get the right answers, but then they put it in the wrong blank. And so just watch that closely as you're putting it in there. Okay. Anything else I can clarify there on that type of problem? Those are good ones to make sure that you know how to do for sure. Those definitely show up a lot on not only, like our exams, but also it's also a good final exam question, I would say. Okay. All right. Well, let's go down to number 2. And let's talk about this one. All right. So on this one, we can't kind of see part of that there. Let me just erase part of this so not make sure that we can kind of see it a little bit better, right? But remember when you're finding these, right, this is saying find f of -2 and then g of -2, and then you're going to add those two together. And so you could have something on the test where you're adding, subtracting, multiplying, or dividing. So make sure that you know how to do all those different types of things, because if it's something that shows up on this practice test here, it's not just these are the kind that are going to show up on the test, but just know how to do these type of concepts. Okay. So specifically, what I want to make sure that is clear on this is when we put a -2 in place of our x here, you need to remember that when you take out your variable, put that number in parentheses when you put it in there. So meaning it's going to look like this. So my f of -2, I'm going to figure that out right here. So that's going to be, so we've got that negative on the outside. In place of my x, I put -2 and then square it, plus 7 times -2 minus 3, right? And then you're going to just use order of operations here to simplify. And some of you might, your calculator might take it from here for you, but those of you that are in my class, and I'm not sure, each instructor kind of got to decide whether they're going to have their students turn their work in or not. So for my classes, you guys are turning your work in, and I expect to see a little bit more work here on how you get to that. Okay, so make sure here you see that -2 squared is what you've got to do first. So that's going to be a positive 4, because -2 times -2 is a positive 4. But then you're multiplying it by this negative that's out in front. So then it does become a -4 there. right? Then 7 times negative 2 is negative 14, and then minus 3, right? And so now you just need to put all of those together, right? So negative 18, and then negative 21, right? When you add all of those together. All right, so that's just my f of negative 2 part. All right, now I've got to go and do my g of negative 2. So now I'm using the g equation. So g of negative 2 is going to be 3 times negative 2 plus 11. So 3 times negative 2 is negative 6 plus 11 is going to give me 5. And then what do I need to do with my negative 21 and 5?
Add them together.
Yeah, don't
Add them
forget
together.
to do that last step of adding those together, right? So when I do that, I'll just kind of write it right here. Negative 21 plus 5 is going to give me negative 16. All right, and so then that would be my answer on that first part. Okay, and similarly, you're going to be doing kind of the same thing down here on part B, but now you're just having, you know, the numbers are being divided by each other in the end instead of being added together. Do you guys want me to do that one, or are you feeling okay?
Yeah, can we do it?
Yeah, can we do it just to be safe?
Yeah, you bet. Let's see. Does everybody understand where to find the practice test? It is just, so when you go into your modules, there should be something there that's talking about like preparing for the test, and all of the teachers should have it there. But, and so it's just in there, it just says it's like a practice on there. Does that make sense? Let's see, just trying to think if there's a way that I could send it to you too on here. Not sure. Yeah, not sure I can see a way to do that on there, but let me just show you, maybe this will help. All right, so in Canvas, I mean, it should look really similar in a lot of the courses. I mean, your teacher could have it looking a little bit different than mine. But when you go in there, there should be an area, oops, caught up, and then, so there's a place for exam 1, and then underneath here, when you have the exam 1 information, it's just inside there. And it's just these little extra practice modules that are just, and there's the key for it too. Okay, so hopefully you can find that on yours. Let's see. Do you think that I would be able to send it? I don't know. I've never sent any attachments on WebEx before. I use something different in my classes, so this is where I have my office hours. So question. Let's see. Yeah, I don't see a way for me to send it. Well, if some of you know, and you want to tell me, that would be great, but I don't think that notes would let me. Okay. But you can, like I said, you should be able to find it in your Canvas course. And if not, if you want to leave me your email or whatever in the chat at the end, I can, email it to you also. So it would work also. Just don't see a way for me to do it on here. But maybe I'm just not sure. All right, well, let's look at that other one. So if we have, I'll just put it over here. So the part B was f of 1 over g of 1, right? So this time we're putting 1 into our functions instead. And so we'll have negative 1 squared, right? Make sure you remember that negative's on the outside because that's going to change what you get for your answer there. Plus 7 times 1 minus 3. So that gives us negative 1. And then plus 7, and then minus 3. And so negative 1 plus 7 is 6, minus 3 is going to be a positive 3 on the top. And then do the same thing with the g of x. Now we're putting 1 in place of x there, so 3 times 1 plus 11. So 3 plus 11 is 14. So 3/14 is what you should get for that answer there. Right? All right, let's look at, so this absolute value equations is something that is one of the most recent things we talked about. So let's make sure that everybody is understanding absolute value equations really well too. So remember, when you have an absolute value, you've got to look at both the positive and the negative, because the absolute value of negative 3 is 3, but the absolute value of positive 3 is also 3. So there's two different numbers that get us to the same answer. So we've got to look at that negative, the opposite possibility there. So we'll always be making two equations when we're working with these absolute value equations. Our first one is going to look just the same, just removing the absolute values. Right? And then the other one, we just need to leave one side the same, so I'm going to keep that 3x minus 7 the same and change the other side to negative. Right? So you have to make one side of the equation negative and leave the other side positive. And like I said, some videos will change like that to negative 3x plus 7 equals positive 11, and you'll get the same answer. I just think students forget sometimes to distribute the negative through to everybody on that. And so that's why I usually just change the number that's by itself there. Right? And then you're just solving these just like normal equations from there. Right? So here we need to add the 7 over. So 3x equals 18. So that means x must be 6. Here we'll add 7 over. We get 3x equals negative 4. And then divide by 3, x equals negative 4/3. So we came up with two different answers. And so with absolute values, right, you're going to come up with two different solutions. Because both of these solutions will make that true. Right? Just like talked about over here, the negative absolute value of negative 3 is 3, absolute value of 3 is also 3. Right? So there's two solutions there. Okay. All right, what about trying to graph something like this? Right? We want to use a table of values to help us graph some of these. And remember, if you're not sure, when in doubt, if you're like, I'm not sure how to graph that, making a table of values is always a great idea. And sometimes you're going to need, maybe, 5 points to be able to really see what it looks like. But on the absolute value ones, you want to always look to see, like start off and look at just this part. This has the absolute value of -3. And you want to think there, well, what value for x would make this 0? When x is 3, right, that's going to make this 0. And so that's where I kind of want to start on here. So because 3 is going to be a really important part of this. Actually, I'm going to do this in a different color so it's easier to see here. All right, and then you want to do numbers that are on either side of 3. So meaning I'll want to do, 2 and 1. And then I want to do some numbers that are bigger than 3. So maybe 4 and 5. Right? So you always want to figure out where that kind of spot is that's making this 0. And that's going to make it easier for you to graph these and make sure that you have all the points on there that you need. Okay? And then you can just kind of put those in here. So we've got the absolute value of 3 minus 3 is 0, and then I subtract 2 off of that, and I get -2 for my answer there. So I'm just kind of extend these over, and I'll just do my little work here in between. All right? So when I put 3 in, out comes -2. So I'm going to have over 3 up 2 will be, it's kind of hard to see. These don't match up with those little tick marks don't match up with the grid lines. So, but it looks like it's about there. All right, and then just keep going and try and put in some more of these. Right? Oops. So the absolute value of 2 minus 3. 2 minus 3 is -1, but the absolute value of it is 1. And then if I subtract 2, I get -1. All right? So if you need to do, a little bit more side work and stuff out to the side, that is just fine. If you can, figure it out from here, that's great too. So we're going to go over 2, and then, oh, whoops, wait a minute. What did I do there? Sorry. Nobody even said anything there. I've got that in the wrong spot. Totally. I think it just threw me off when the grid was not quite matched up there. I need 3 -2. I did 3 +2, right? So over 3 down 2, and then over 2 down 1. Okay? And so then I'll keep going with this. Keep doing yours on your paper, and I'll do mine here. And then you can see, oops, what did I do? And so when you graph it, it should look like a V-shaped graph. Absolute value graphs are always V-shaped. Right, so they come down at a sharp point. So please, make sure it doesn't look rounded or anything on the bottom. It comes down at a sharp point, right? Because that absolute value is making it turn back around, right? It's making it go back up, and that's what's happening. It's kind of like, so that's why it's like, would be continuing down like this, but because of the absolute value, it flipped it up there. Okay? And then just be careful. There might be some questions about domain and range a little bit later in here, but I want to talk about it right now just because students tend to make some mistakes with this. And so let's talk about it now. If I wanted to say what the domain of this is, remember the domain, you're always looking at the graph from left to right. So how far out to the left is this going? Okay. Yeah, so it's going out to negative infinity. Just because my graph stopped here, right, doesn't mean it's stopping here. That arrow means it's going on forever, right? So it's going to continue out to negative infinity and to the left, and then to the right, it's going to be going to positive infinity. All right, what about the range? So range, I'm always looking at bottom to top. So where's the lowest part of my graph? Negative 2.
Negative 2.
It includes it, right? So we got to use a square bracket, negative 2. And then how far up is this going to go? Well, this is going, yeah, it's going up and out forever. So perfect. It's going out to positive infinity. Okay, so make sure you're really clear on that domain and range. Right? Domain, you're always looking at from left to right, range, bottom to top. Okay. All right, and please speak up if you have a question, if you're like, I'm not quite sure I'm seeing that. You're not going to be alone, so please ask, okay? Ask for the benefit of others, all right? That will always be a good thing. They will be thanking you for sure. All right, let's look at this next one. So this one, we're graphing a system of linear inequalities. So we're graphing two different linear inequalities on the same grid, right? Now there's a couple of ways you could solve these and you could graph it. I'm going to show you one way. If you like another way better, that's just fine. Like you could find the x and y intercepts and then figure out what the test points are for it. But the way I'm going to show you it, I just think it is usually faster, so that's why I like it. All right, so let me write these over here. So I'm trying to get these into the y equals mx plus b form, meaning I'm trying to solve this inequality so that y is by itself. So I'm going to first subtract x over, and then I'll have negative 3y is less than negative x plus 6. And then I'm going to divide by a negative 3. What happens when I divide by a negative?
We have to flip the sign.
Yeah.
We have to flip the sign.
Yep, the inequality sign. Thank you. Yep, so I'm going to flip that the other way. All right, so it's going the other direction, and then that's going to give me 1/3 x minus 2, right? Because I have a negative divided by a negative there. So it's going to make that one positive. All right, and then let me just go ahead and solve this other one too. To get y by itself, all I need to do is subtract that negative 3x over. So that will give me y is greater than or equal to negative 3x minus 3. All right, and then I'm going to do these in two different colors, hoping that will make it a little bit easier to see what I'm talking about. So this first equation, right, when I graph it, I'm going down 2 places. So my y-intercept is at negative 2. And then from there, I'm going up 1 and then to the right 3. So up 1 and right 3 is about here. All right, and then I can do that again, up 1, right 3. All right, or I could go down 1 and left 3. All right, and so this is where my line's going to be. It doesn't have the equal to part on this one, so that means it needs to be a dotted line. So make sure that you're really careful whether you're choosing dotted lines or solid lines on this. Okay, and then after you draw your line, then you got to decide which side of this is going to be shaded. Well, I have this greater than symbol, right? greater than symbol, so that means it needs to be the stuff that's above the line. So it's all of this. Right? And if you like choosing the test point, that's fine too. You could choose like 0, 0 as your test point and put it in there. And you'd see that 0 is less than 6. That's a true statement. So that means 0, 0 is a part of the solution. So that means this whole thing is a part of it. Okay, but if you can look at this and say, y is greater than that line, and see that this is, the stuff above it is the stuff greater than, it just makes it go, I think, a little bit quicker. Okay, and then let's do the other one. That one in purple here. All right, so this one we're starting at -3, and then I'm going to go down 3 and to the right one. Or I might go up 3 and to the left one. Oops, that doesn't look right. It's not on the line very good. Let me see here. 1, 2, 3. Oh yeah, 1, 2. Okay. I just have that one in kind of the wrong spot. And this one is a solid line. So I'm going to be drawing a solid line through here. And I know it's solid because it has that equal to part. Okay. And it'll be a lot easier on your, when you're graphing it, because you got some nice little grids and stuff, and it's going to be really similar. Like the test is going to be similar to what your quizzes look like, and so you're used to how the homework's being done and how these are, and so it should make it pretty easy to get these graphed on there. And then after you draw this purple line here, then we need to decide which side of it needs to be shaded. It's greater than, right? Or equal to. We got the equal to part because it's a solid line, but the stuff greater than it is going to be the stuff above the line. So that's all the stuff here. But then your answer is just the parts that overlap each other. So that is kind of in this area here, right? You see how stuff with where I have the green, right? It's just going to be that part there. That is your solution. So anything that is greater than this line, right, or greater than or equal to this line, they both would overlap up here in this area. Okay, what questions can I answer about that? Make sure that's clear. Sorry, my drawing isn't like... It looks very scribbly, but as long as it's making sense, that's what matters. All right, so let's solve this system. And let's solve it usually, I'm just going to say it this way, usually as far as like the final exam goes and stuff, you won't usually put like a 3x3 as something that you have to solve using matrices, but a lot of times they will have a 2x2 where you have to solve using matrices. So it's good to make sure that you know how to do it both ways. But for me and, my class, like if it asks you to solve something using matrices and you're not quite sure how to do that, I'd say try and solve it, like with the substitution or elimination method and see, what you come up with for answers there. And then that might help you to, work on it with the matrices. But if you still can't get it that way, try the best you can with the matrices because you can't get full points on it unless you solve it that way. But you will still get some points in my class if you solve it one way, right? Even if it wasn't by matrices. So, okay, but let's talk about this number 6. So I'm going to label these. equation 1, equation 2, and equation 3 so that I can talk about which equation I'm trying to deal with, right? And so I want to ask you, which variable, in your opinion, looks easiest to eliminate first? What are you thinking on this one?
I would say the Z.
Why are you saying Z?
Because that middle one has a
Positive Z, and then the two on the top and on the top of it and the bottom of it are
so
both
you're not even going
negative.
to have to multiply the rows by anything, right? So if you do equation 1 and equation 2, right? So let's do those two. So I've got, let's write them out over here again. My equation 1 and my equation 2. Then I can see right off my Z's cancel out without, I don't, like I said, I didn't have to multiply by anything. So that's the best case scenario, right? That's the easiest thing to do there. So I agree that I would pick the Z's too. You could pick any of them though. If you're like, X's look good to me or Y's look good to me to eliminate, that's fine. You could totally do that. You'll still get the same answers in the end. All right, but let's add the rest of these together. So I'll get 3x plus 4y equals 19. All right, so that gives me equation 4. So this gives me my new equation that I'm trying to get to, right? So I eliminated one of the variables, and now I'm left with this. Okay, now let's go and look at two of the other, right? I got to look at another pair of equations. So if I look at equation 2 and equation 3, right? And again, I've got to eliminate the same variable that I did before. So I can't eliminate Z's over here and then try and eliminate X's in my other two. You've got to do the same variable. And so when I do that here, let me rewrite these out. And so again, nice, when I add these together, I see my Z's cancel out, they eliminate, which is awesome. So then I'm left with x plus x is 2x, 3y plus y is 4y, 14 plus 4 is 18. So now I have my new equation that I'm going to call equation 5. Right? All right, then somebody tell me from here, what would you do to, what would be your next step after we eliminated Z's in both of those?
Take 4 and 5 and eliminate
Take
another
4 and 5 and eliminate
Yeah.
another
And
variable.
Which,
I would say
4.
probably 4. Or
yeah, eliminate the y.
Probably the
Yeah,
y.
the y looks like it's going to be easiest to eliminate. And maybe before I move it over there, I'm just going to show that I'm going to multiply this one by a -1, right? Because when I do that, that's going to make this a -4y. And when I add it to my other 4y, those would eliminate, right? So when I distribute this -1 through, I'm going to have -2x minus 4y equals -18. Right? So all I did was try to look and see what variable would look easiest to eliminate now. Right? And so now my y's will eliminate when I add those together. When I add the other parts together, 3x minus 2x is just a 1x, and 19 minus 18 is 1. All right, so I found part of my answer. Remember, if it asks you to write your answer as an ordered triple, you always have to do the x, then the y, and then the z. We found x was 1, so it's going to go in that first spot there. Okay, now what can I do with this? So I know x equals 1. How can I use that to find another variable?
Plug it into equation 4 or 5.
Plug it into equation 4
right?
or 5
Yes.
and solve.
So I'm going to just
for y.
put it in here. Does that look good? Because if I put 1 in there, then all I have left to solve for is this y. Right? So let's do that. So I have 2 times 1. Right? I know that x is 1, so that's why I'm putting 1 in place of x. And then 2 times 1 is just 2. And so I need to subtract that over to the other side. So I get 4y equals 16. And then I'll divide by 4. So y equals 4. So I found out another part of my solution. Okay, and now I found that y is 4, and I know that x is 1. How am I going to go about finding z?
You plug both values
You
into
plug
one of
both
the
values into one of
original
the
equations.
3
Yeah,
original
and which equation
equations.
looks easiest to put it into, do you think?
I would say equation.
I would say equation
Yeah, I agree, because
3.
there's nothing out there to multiply by, so I think that would be a great one to choose. All right, so I'm going to go just write this down that it's equation 3 that we're choosing, right, to plug these numbers into. So in place of x, I'm going to put 1. In place of y, I'm going to put 4. And then I'm solving for z. So 1 plus 4 is 5. And then I need to subtract 5 over. So I got negative z equals negative 1. But I don't want to know what negative z is. I want to know what positive z is. So z equals positive 1. All right. So my answer, oops, I should put that back up here. All right, so I've got my ordered triple is 1, 4, 1. And that would be my answer. All right. So remember, you would take 2 equations, eliminate 1 variable. Pick 2 other equations, eliminate the same variable. Then take your new equations that you made and eliminate one of those variables to come up with your first answer. All right. Then take that answer, put it back into either equation 4 or 5 to solve for your second variable, and then take both of your answers and plug it into either equation 1, 2, or 3 to find your last variable, your third variable. Okay? Does that look good? All right, and somebody wanted to work through one where we ended up with some infinite solutions, and so I want to talk about some like that. Let's see if I find a good one here to do. Just trying to decide if there's a good one to do here. All right, let's try this one. Maybe what I'll do this on a different page just because I think we're going to need more room here. All right. And did you want to solve this just, did you want to use matrices or?
Yeah, so for the homework.
Yeah, so for the homework, I was supposed to do it with matrices. I never figured out how to do it, but I was supposed to, so I was hoping to figure it out.
Okay, and it's going to be good to just like look at, you know, trying to solve one with matrices. So let's look at this one. So if I have my first equation as x minus y plus z equals 4, and then 5x plus 2y minus 3z equals 2, and then 4x plus 3y minus 4z equals negative 2. Let me double check that I have this all correct. I always like to do that when we have so many equations here. Because if you start writing it down wrong, right, then it's going to be bad. You're never going to get to the right answer there. Okay, so then we've got to change this into an augmented matrix, right, to solve it. And remember that when you're solving matrices that are 3 by 3s, your goal is that you want to end up with something like this. And when you do that, then you know what your x, y, and z is. However, usually we don't have to find all 3 of these to be zeros, and I probably am not going to. I'm going to stop when I get down here to this one, and I'll show you what I mean. And then you can kind of do the rest by back substitution, or if it's, an infant solutions, then you have to write out the equations. So, but normally this is, if you told you that it wants you to do reduced row echelon form, that's getting everything to be zeros and ones. Okay, and I talked about in my class kind of a little mapping that makes it a little bit easier to solve these. So you always want to get 1 in the upper left-hand corner, then go down and make this one a 0, then go over and get that middle 1, then come here and make this a 0, and then that a 0, and then that a 1. Okay, so this is kind of a little way. And the reason why I say to use this kind of mapping is if you're doing that, then you won't end up like, I don't know if some of you have been frustrated with matrices because you change something into a 1, and then when you go and do the next step, now that 1 becomes something different, and you're like, right? And so then it just gets really frustrating. But if you follow this little method, then that won't happen, okay? So let's write this down as an augmented matrix. So I've got 1, negative 1, 1, and then 4 on the other side. 5, 2, negative 3, and 2 on the other side. And 4, 3, negative 4, and then negative 2 there. And I can't stress enough to double check to make sure that your negatives are where they should be negative, your positives are where they should be positive, because, there's just nothing more frustrating than working it through and then just realizing that you missed a negative somewhere, something like that, okay? All right, so the first thing I wanted to do is get a 1 in the upper left-hand corner, and that's already done, so that's awesome, all right? So now I want to go and make this 5 into a 0, right? And so what I'm going to do is I'm going to actually use the 1 above it to help me do that. Because if I take and multiply this 1 by a negative 5 and then add it to 5, that's going to give me a 0 there, right? So remember that the 4 things you can do with matrices is you can switch any 2 rows, you can add any 2 rows together, you could multiply a row by the same number, or you could multiply a row and add it to a number, right? So those are kind of the 4 things you can do there. And the way I'm going to write this down is just I'm going to say I'm going to take negative 5, let's see, put this in red over here. So I'm going to say negative 5 times row 1 added to row 2. And whichever one I'm adding to is the one that's changing, right? Because I'm trying to change that 5 into a 0. So only row 2 is changing on this. So I would say it's a good idea for your next step just to write out, right? You know that your row 1 is not going to change and your row 3 is not going to change. We're just working on row 2 here. Okay, and when you get more used to matrices and stuff, you can do, more than one step in each matrix. But I think it's when you're just learning how to do them, it's good to kind of keep that separate. All right, and then I'll just do a little bit of workout here to the side so you can see what I'm doing, because sometimes it gets a little confusing. All right, so I'm taking -5 and I'm multiplying it by row 1. So that's going to give me -5, and then +5, and then -5, and then -20. All right, and then I'm adding it to row 2, just how that row 2 is. So I'm just going to write out my row 2 here. All right, and then if I add these together, right, I get a 0, which is what I wanted there. I get a 7, I get a -8, and I get a -18. So this is my new row 2, right? So I'm going to put that in here. So I have 0, 7, -8, and -18. Like I said, you don't have to do this little side workout here. You know, in your mind, you could be doing -5 times 1 is -5 plus 5 is 0. -5 times -1 is +5 plus 2 is 7. Right? So you can do all of that in your head if you want to, but sometimes it's nice to see the workout to the side in case you make a mistake somewhere. Okay? All right, so now I want to go, and I actually could do one of two things. I could either make this 4 into a 0, or I could change that 7 into a 1. So those are kind of two, you know, it doesn't matter, you know, which one I do first on this. And so I'm going to go ahead and make this 4 into a 0 next. And then we'll kind of go from there. All right, so if I make this into a 0, again, I'm going to do something similar that I did here. I'm going to use row 1, right? But this time I'm going to do -4 times row 1, and then add it to row 2 to make my 0. Right, so again, the only thing that's changing this time, oh, sorry, did I say row 2? I meant row 3. Right, I'm adding it to row 3 because row 3 is the one that I want to change. Ooh. All right, so my row 1 staying the same, my row 2, and then my row 3 is the one that's going to be changing. All right, so -4 times 1 is -4 plus 4 is 0. -4 times -1 is +4 plus 3 is 7. -4 times 1 is -4 minus 4 is -8. Right? And then -4 times 4 is -16 minus 2 is -18. Okay, now what do you notice at this point? There's something weird. Looks kind of weird here.
The second two
The
equations
second two equations are both the same.
So that is telling me that we're gonna, you know, we got this dependent system that's happening here because these two ended up being the same, right? And so when I go through and I do this, I mean, normally I wouldn't come down here and make this a 0, but because I can see that these two are the same, I'm going to just multiply my row 2 by a -1 and then add it to row 3 because I see that I've got this dependent system that's going on here. And so I know that means it's going to be infinite solutions when I get these two are exactly the same thing, right? And so then let's see what happens here when I do this. All right, so again, my top row is staying the same. My second row is also going to stay the same. It's just the one that I'm adding to is changing. All right, so I'm going to multiply by a -1 and then add it to it. And when I do that, that gives me zeros all across the board here. Is everybody with me there? Because I know that's kind of weird, but ask questions if you're not quite sure or if I can clarify something there.
Yeah, I got it. I remember that means infinite solutions when it's all zeros.
And then if it had all zeros except like there was a 3 or something there, then that would mean no solution, right? So we need all zeros on the bottom to mean infinite solutions.
Like the equivalent of 0
It'd
equals
be like the equivalent of 0
yeah,
equals 3.
Exactly, right?
Type of
0
thing.
can't equal 3, and so that would be a no solution, right? When you had something like that, when you solved it out with the variables, not with the matrices, right? Okay, so then what happened here, right? The z went away. And so when you're writing down, we're going to put this in terms of z. So this is, you know, if it asks you to write with parameters in terms of z, that means that everything, like all the equations that you write, need to have a z in them. So the first one, right, so we're going to end up figuring out what x equals, what y equals, and what z equals. Well, z is the one that eliminated out here, and so z equals z is the first one that we're going to have. All right, so whichever one eliminates out there is the one that you're going to be talking about. Now let's look at this next. So if we write this 7, -8, and -18, I'm going to change that back into an equation. That would say 7y minus 8z equals -18. Because remember, this first column are my x's, my second column are my y's, and my third column are my z's. Right? So that's how I know that I have the y goes with the 7 and the -8 goes with the z. All right, now to find my y equation, what y equals, I just need to solve for y. So I'm trying to get y by itself. All right, so to do that, let's add the 8z over. So I get 7y equals 8z minus 18, and then I'd need to divide everything by 7. So it might want it written out like this. So y equals 8/7 z minus 18 over 7. Right? Or you could just, I mean, it's the same thing if you did 8z minus 18 all over 7. Could write it that way as well. All right, so there's that. And now I need to go and find my x. So usually this x one is kind of the trickiest one to do. So I'm going to write out this equation, right? Again, so this top one here, how I have in my last matrix, that's x minus y plus z equals 4. And remember, I need it in terms of z, right? But I have a y in here. And so this is where it gets a little bit tricky, because now I need to take what I got for my y, right? And I need to put that in place of y here so that I can simplify this. So it's just, all we have is x's and z's. I don't want any y's in there for this last equation. Okay, let me write it over here so we have a little bit more room. So it's going to say x minus, and I got to have this whole thing in parentheses because it's minus all of this, 8/7 z minus 18/7, right? And then plus z equals 4. And then let's distribute that through. So x minus 8/7 z plus 18/7 plus z equals 4. Well, I need to get a common denominator there to be able to add my z and my negative 8/7 z, right? So it's kind of like I'm saying 7/7. All right, that's the same thing as 1z, but that will give me a common denominator there. So I got x, negative 8/7 plus 7/7 is negative 1/7 z, right? Plus 18/7 equals 4. And this is really like on these fractions and stuff like that, this is where it's really nice to have a really good calculator that deals with fractions so that you're not worried, am I just messing this up because of the fractions or something like that, right? Because now we got to get x by itself, so I'm going to add the 1/7 z over, right? And I need to add, or sorry, subtract my 18/7 over. All right, so I'm doing like 4 minus 18/7. So when you do that, right, so 4 minus the 18/7, let's see, so we'd have 28/7 minus 18/7, so that's going to give us 10/7. And then I still have that 1/7 z. Holy frijoles, right? Hopefully on the ones that they give you, you don't have as many fractions and stuff, but it's still doable. But all it means is that you've just got to solve each of these so that z, you know, so everything on that right side of the equation only has z's in it. Does that make more sense for the person that asked about that one?
Yes.
Yes.
Yeah.
I appreciate it.
You know, it is a little bit weird. So.
And the steps for the augmented matrices.
And the steps for the augmented matrices helped me a lot because I didn't understand the steps before. It just seemed like it was
you're
all over the
welcome.
place. So thank you.
The little mapping.
Yeah.
Yeah.
That helped a lot.
Yeah, I
that
don't
helped
know
a
why
lot.
more instructors, and it's not on the videos and stuff like that. It really, I think for the students that do it, they're like, oh, I can totally do this now, right? So, good.
Yeah.
All right, well, let's go back to that other review, and we are about halfway through it. We just did matrices with the 3, so I might skip this one. But just remember on ones that are a 2 by 2, right, when you're trying to do this one, you get 1 in the upper left hand, then go down, make that a 0, make that a 1, and make that a 0. So the mapping's kind of more of a U shape on this one, but most people can do the 2 by 2s. There's just not as many steps and stuff to do there, but that's going to be the best way to do that kind. Okay. All right, let's look at this absolute value inequality. These are always good ones to make sure you know how to do. All right, so when you're solving either absolute value equations or absolute value inequalities, you first need to make sure that you're getting that absolute value part by itself. And right now it's connected to this divide by -2. And so the first thing I need to do is multiply both sides of the equation by -2. And remember, it's not just when you divide by a negative. A lot of times students just think it's when you divide by a negative, but if you multiply or divide by a negative, it flips that inequality sign. All right, so my 2's are going to divide out there, and then I'm going to be left with absolute value of x plus 5, but my sign was a less than, so now I need to change it to a greater than because I multiplied by a negative number. And then -7 times -2 is a +14. Okay. And then just like we did with the equations, right, with the absolute value inequalities, you still need to write out two different statements. Our first one is just going to be the same without the absolute values. So x plus 5 is greater than 14. And then the other one, the x plus 5 stays the same, but my 14 is going to be a negative 14, and that's like I multiplied that by a negative 1, which flips that inequality sign, right? So this has to be a less than negative 14. So flip the inequality sign, change that number to its opposite, okay? And then the other thing to point out here that I want to make sure is clear is this symbol that we have here to start off with before we make our two equations. This is telling us whether we want an and statement or an or statement. So when you see, I'm going to write these over here, if you have this or this, right, these are greater than signs. And so I tell my classes to think of greater, right? This or, remember back when we talked about unions and intersection, or meant we wanted the union, right? But if it starts off with a less than or equal to, then I want you to think of it as less than, right? Just a play on words to help you remember. And when we had an and statement, that meant that we want the intersection, okay? Or where it overlaps. So in this one, since it starts out as a greater, right, this is an or statement. So I'm actually going to write the word or in between here to help me remember in the end what it is I'm trying to find. Okay, so then let's just solve these down the rest of the way. Get x by itself. Oops. So this is what you come up with, but now we got to, graphing it is going to make it a lot easier to figure out what part is our solution. So let me see, so I'm going to draw just negative 19 is somewhere over here, and then somewhere further to the right is my positive 9, right? And then again, I'll do these in two different colors, just to hopefully make it stand out. So 9, so everything greater than 9, right? So it's an open circle here, and everything to the right. And then let's do the other one. Open circle at negative 19, and all the stuff less than that, right? And so since it's an or statement, it's the union, we want everywhere I see the blue graph and everywhere I see the orange graph, right? It means all elements that are in both of them. So how would I write this in interval notation? Can somebody tell me what you would do there to write that answer?
You would write
negative infinity, comma,
negative 19,
Awesome.
within parentheses,
a union,
Yep.
and then a union,
and also in parentheses,
9, comma, infinity,
Yes.
positive
Awesome.
infinity.
Good job. And so that would be your answer. Right? What that is in absolute value. Okay. Oh yeah, and some of you wrote that in there. Right? Just be careful with your negatives there. Okay, let me see if I can understand. I'm not sure who 13852 is, but maybe if you can talk, can you tell me what your question is, just to make sure I answer it correctly? understanding your question, if it starts with greater here, then it's an or statement always. If it started off with a less than, then it's going to be an and statement. All right, so if this was going the other way instead, right, less than, then, if we were looking at this and they were graphed this way and it was an and statement, well, and is where the intersection is, and these guys don't intersect anywhere, right? So that would be a does not exist, because we want to know what the overlap is, and there is no overlap there. So that's how, okay, all right. Awesome, yeah. Just want to make sure that I, so greater is the union, less than is the intersection.
Can you hear me?
Yeah, I can now.
Can you hear me?
So a question I have is
You have to simplify the problem first. You can't get the initial
because
problem.
notice, that it starts off, right, our original question was a less than symbol, but we're not using that. We've got to get that absolute value by itself first, and whatever the symbol is there before you split it into the two different statements. That's the one you're using. Does that make sense?
Yes, thank you.
Yeah, so get that absolute value by itself, and that's going to be there. Whatever symbol is there is kind of how you can see that. Okay, and somebody said they do want to do number 9, so let's make sure that we don't skip that one. All right, so on this one, remember that with domain, when you're looking at the equation of a function, right, usually on most functions, right, our domain is going to be all real numbers, or negative infinity to positive infinity, right? It's, usually, any function is going to be that way, but there's 2 exceptions, okay? So these are our 2 exceptions, okay? One is if you have a fraction, and the other is if we have a square root. Okay. Well, with a fraction, we can't have the bottom divide by 0. So the denominator cannot equal 0. All right, so that's kind of our exception there with when we have a fraction in the function. If we have a square root in our function, then we have to remember that we have to have a positive value inside the square root, right? So we're kind of thinking about what it can't be, right? We can't have any negative numbers inside the square root, okay? So I'm just going to write it that way. Can't have let me write it this way. Can't take the square root of a negative number. That'll be a little bit more precise. And we can do that and find out those are imaginary numbers, but functions don't have these imaginary numbers in them. They have to have real numbers in them. So that's why I'm saying you can't do this in the real number system. So can't take the square root of a negative number. All right. Okay, so on this number 9, we don't have a square root in there. We just we have a fraction. And so we said the denominator cannot equal 0. So I'm going to take whatever is in the denominator, that x minus 7, and I'm going to say it cannot equal 0. Right? And then I'm going to go ahead and solve it. I don't care what's on top of the fraction. That doesn't matter. My top number could be 0. I can do 0 divided by a number. That just gives me 0. But when I do a number divided by 0, right, you try that on your calculator and it says error or domain error, and that's because you can't divide by 0. So if I was to solve this, right, I'd be adding 7 over, and so I'm saying x cannot equal positive 7, because if I put positive 7 in place of x, that's going to give me 0 on the bottom, and I can't divide by 0. Right? So it can be anything, just not 7. So if I was thinking about it on a number line, here's 7, and I'm just saying it can't be 7. So it's going to be like an open circle here, right? It can be anything to the right of 7, anything to the left of 7, just not 7. So if I was to write that in interval notation, right, I can have all the numbers out to negative infinity up to 7, but not including it. So I've got to use a parenthesis. And then union, I can also have numbers bigger than 7. Right? So this is the way I write that in interval notation, that I mean everything, just not 7. Okay? Does that make sense on those with the domain? Right? And then similarly, like if you were doing one with a square root, let me just do one over here really quick. Right? So if we had something like this, then whatever is inside the square root, you'd want to put 2x minus 3 has to be greater than or equal to 0, and then solve that for x. And those will be all of the values that do work. Right? So I can add the 3 over. So 2x is greater than or equal to 3, divide by 2. So x can be anything bigger or equal to 3/2. Right? But it can't be, so that's like 1.5. So it couldn't be 1, it couldn't be 0, it couldn't be -1. Right? All of those numbers, if I try to put those in place of x, that's going to give me a negative inside my square root, and I cannot have that. So that's why I want to put it greater than or equal to 0, because anything greater than 0 gives me the positives. Okay? All right. What other ones here? We just did one like number 10, so I'm going to kind of skip that. Just kind of look through here and see which ones you feel like you need help with. So solving the inequalities with an or statement, graphing an equation, finding the values on the graph. Let's do this one really quick, and if we want to go back up and get some of those other ones, then just let me know. But I do want to talk about this because this sometimes is a little bit tricky. All right, so when I'm saying on part A, you know, what are all values of x such that f of x is 1? Well, it's saying, really here it's saying, what is x when y, remember f of x is the same thing as y, when y equals 1? Well, here's 1, right? And so I see that I have two different, oops, let me do different colors so you can see it better. So I can see at 1, right, I have two different answers there, right? So x could be 1, right? Or x could be -4. Right? Both of those is when y equals 1. Okay? But on this one, when it says f of 3, that's saying when x is 3, what is y? Right? So on this one, do a different color here. When x is 3, so here is my x equals 3, right here. And so if I try and see where that intersects with the graph, it's going to be right there at -3. So when x is 3, it hits the graph at -3. So y equals -3. All right, so make sure you're just understanding whether it's giving you your x or giving you your y. Because a lot of times students miss this question because they're reading this like it was part B, like they're thinking it's saying what is f of 1, but that's not what it's saying, right? It's saying when y is 1, what is x? Okay. And then the range, right? So remember, the domain is from left to right. The range is from bottom to top. What would the range of this be?
Negative infinity to
Does it
positive
include
3?
positive 3 or not?
It does include positive 3.
So
It
that
does
means we
include
need to
positive
have
3.
a little bracket there, right? Oops. Okay, good job. All right, so then there's another inequality statement. This one is an and. So we can go back and get any of these that you want. There's this story problem with the moving truck. There's writing an equation of a line that goes through 2 points. Right, finding an equation of a line that's perpendicular to another line. Solving a system with either substitution or elimination. There's kind of a little plane problem, right, with the wind and against the wind. And then there's these correspondence, finding the domain and range if you're just given points. Okay. You can just write in the chat any of these numbers that you'd like to look at. Like I said, we're probably not going to be able to get through all of them. All right, I'm seeing 19, so that looks like a good one to, again. So it looks like most people want to try this one, so let's do it. Okay, so we're dealing with either, these plane problems or boat problems, then you're really using, you've got to remember that you're using this equation, distance equals rate times time, right? Because they're giving you information about distance. They're giving you information about the rate and giving you information about time. Okay, so we've got to kind of think about those. So I sometimes like to set this up as in like a table form, because I think sometimes that can really help you organize your information, but it's up to you if you think that's going to be helpful or not. Okay, so so let's look at what is given here and how to set this up. Well, actually, before I do that, let me talk about the rate really quick, because sometimes this is confusing to people. Because notice it's talking about wind speed here, and it's also talking about the speed of the plane, right? So it's giving you two different pieces of information here, and both of those things together make up the rate. So I'm just going to write over here just to make sure that it's clear. Rate is comprised of the speed of the plane plus or minus the speed of the wind. Right? And I put the plus or minus there because the plus is if you're going with the wind, right? It's actually pushing you faster, where if you're going against the wind, it's actually slowing you down from what the plane is actually going. All right, so understanding that this rate is made up of those two things is probably one of the biggest things that will help when you're doing these problems. Okay. All right, so let me set up my little table here. I've got my distance, my rate, and my time. And I'm given information about each of these things. And I'm given information so we've got, I'm going to write it down the way they do so we can talk about what this means. So we've got headwind, right? So Rhonda flies a small plane a distance of 912 miles into a headwind, and the trip takes 8 hours. The return flight takes less time because the wind is blowing in the same direction, right? So we got a headwind, and this other one, if it's going with you, it's called a tailwind. So they might use that word too. All right, so headwind means that it's slowing you down, right? It's coming, to the front of your plane and it's slowing you down. So that's going kind of against the wind, where tailwind is pushing you faster, so that's like with the wind. So they kind of use those two different, that different type of terminology in each question. So making sure you understand those are the same thing. All right, so let's fill in what we know here. Well, we know that she goes 912 miles, and she does that both ways because she's going somewhere, and then she says there's a return flight, right? And so that means she's going still the same amount of miles. All right, and then we know stuff about time, right? So with the headwind, it takes 8 hours, and with the tailwind, it's going to take less time because it's pushing you faster, and it only takes 6 hours. Right? And so the things that we're trying to find here, remember there's two variables here, the speed of the plane and the speed of the wind. So I'm just going to say, just to make it a little bit easier here, I'm going to say x is the speed of the plane, and I'm going to say y is going to be the speed of the wind. Right? I've got two different things that I'm trying to find there. So with the headwind, is that going to be x plus y or x minus y? How do I know whether I'm doing the plus or the minus? What do you guys think? X plus y or x minus y? Heather, you said minus. Are you able to talk to us and tell us why you said minus? I don't know if you're in a situation where you can talk or...
Can you hear me?
Yeah, I can.
Can you hear me?
Now you can.
Okay, now you can. I say minus because the wind is slowing the planes down.
It would be plus.
And it would be plus with the tailwind because it's pushing it. It's helping it move forward.
Okay, so you see that, why it's set up that way. All right, and then you have your two equations here. All right, so my top equation is 912 equals, and I'm going to write the 8 first. It's just rate times time. It doesn't matter with multiplication which one I write first and which one I write second, but I just like my number, right, out in front there. And then my other equation is 912 equals 6 times x plus y. Okay. And then from here, you could distribute the 8 through, and you could distribute the 6 through, but it's actually a little bit faster if you think about, okay, this is saying 8 times all of this, so I could divide both sides by 8. All right, what's 912 divided by 8? Got 114. You guys came up with. So 114 equals x minus y. Right? And so that just kind of simplifies my equation a little bit there. And then on this other one, right, this is saying 6 times all of this. And so instead of distributing it through, how about I get rid of it by dividing both sides by 6? Right? So what's 912 divided by 6? 152 equals my x plus y. Oh, good. It's got the same thing there that canceled out. All right, so now I have my two equations, and let me write those two over here. So I've got 114 equals x minus y, 152 equals x plus y. And some people don't like it with their variables on the right-hand side. They'd rather have them on the left-hand side. It doesn't matter, but if you like it better that way, you can totally switch this around, right? But if we were to add these equations together now the way they are, do you see that the y's will eliminate? So that's awesome. That'll make it easier for us to solve. So 114 plus 152 is going to give us 266 equals x plus x is 2x. And then let's divide by 2. So we get 133 equals x. So what did I just find there? What does that 133 represent?
That's the speed of the plane.
Yeah.
That's the speed of the plane.
Plane speed is 133 miles per hour. All right, so that's part of my answer. Now I need to figure out the speed of the wind, right? And again, I can go back up and do, I'm just going to use that 114 equals x minus y. Actually, I'll do the 152. That'll make it a little bit easier. So if I do the 152 equals 133 plus y, and then to get y by itself, I just need to minus the 133 over. All right, so when I do that, I get 19. And so what does that 19 represent?
The speed of the wind.
Yeah.
The speed of the wind.
So wind speed is 19 miles per hour. Okay. Now, could your wind speed ever be more than your plane speed? Think about this in practical terms.
No.
Why not?
No. You'd be in a hurricane. You'd be in a hurricane.
You wouldn't be flying, would you? You'd be falling. It would not be a good sight, right? So just, make sure again when you're solving things with the two variables that you make sure that you put your answer into the right spot. Because like I said, that's just a common mistake that students make, and I just always feel so bad. I'm like, oh, they got the correct answer, but they put it in the wrong spot. So that's actually why I have my students turn their work in, so I can give some partial credit on stuff like that. So, all right. What other ones would you like to look at? About 10 more minutes. Just kind of slowly go through these and see, just write in any of these numbers that you'd like to look at here. Number 15. All right, the other story problem, right? Story problems are always good ones to try and make some sense out of, right? All right, so let's do number 15 next. All right, a rental truck rental company rents moving trucks one day by charging $35 plus 18 cents per mile. Okay, so I want to talk about, this is going to be a linear equation, and so you're trying to write it in this y equals mx plus b form. And remember that the m is the slope, but we also call the slope a rate of change. And the b is the y-intercept, but we also call that the start amount. Right? So when we're thinking about trying to set this up, do you see that this is a rate? We're saying 18 cents per mile, right? So that's got to be our rate of change. And then $35, they're going to charge us $35 no matter what. If we go, 1 mile, we still are going to be charged that flat fee of $35. So that's our start amount. And then from there, it's going to increase 18 cents per mile. Okay. And so, all right, they have theirs set up a little bit different, right? They said cost, so write a linear equation that relates to the cost in dollars of renting a truck to the number X of miles driven. All right, so instead of my Y there, we're using a C. Okay. So help me set this up. So I'd have C equals what?
18 cents or 0.18x plus 35.
0.18x plus 35. Right, because that 35 is our flat fee. Right, so that's our equation. Then ask, what is the cost of renting the truck if the truck is driven 90 miles? So going up here, it's always a good thing to, look and see, right? It's saying, the number X is the miles driven, right? So we're going to put this 90 where? In place of X or in place of Y? Well, sorry, C.
In place of X.
Yeah,
In
I
place
gave
of
it away
X.
because there wasn't even a Y, it was a C. But yes, it's going to go in place of that X, right? So we'll do C, so we want to know the cost, and the cost of driving 90 miles. So 0.18 times 90 plus 35. Right? And then go ahead and just use your calculator to figure out what the rest of that's going to be. So I got $51.20. So you guys came up with? Yep, looks like. All right, and so make sure you write it as money, right? Because we are talking about the cost of it, right? So $51.20, and that seems reasonable, right? If you came up with, some kind of like if you came up with a negative answer, for instance, you should be going, okay, that's weird. They're not going to pay me money to drive their truck. That would be nice, but that's not how it works, right? So always make sure that your answer seems to make sense, right? That it doesn't seem too high, or if it's negative or something like that when it shouldn't be. Okay. All right, that was a good one to look at. We still have a little bit more time. So is there any of these others that you wanted to look at? Let's go back again to these. Number 20. Let's go back down here to number.
A couple general questions about
Sure. Yeah, go ahead and ask that
setup.
first, then we'll do number 20.
So since this is called a proctored exam, I'm not really sure how that works from home.
Since we have the COVID stuff, it's not really going to be proctored. They talked about using like a proctored, like there's something called Proctorio. It's a little app that you have to have set up on your computer and stuff like that. And they might require that for the final exam, but the department decided that on the 3 exams that we take, like the chapter exams and stuff, that those will just be kind of on your honor. So, okay, so it's not really a proctored exam because of all this COVID stuff. It's just, and I think that the math department just felt bad because, there's some students that don't have, because with Proctorio, you have to have a webcam, and, it kind of like watches you as you take the test and stuff like that. And I feel like that's really stressful for a lot of students too. So, anyway, so don't worry about that. As we get closer to the final exam, the math department will let us know a little bit more of how that's going to look. But does that make sense?
Yes.
Okay.
And then
Yes.
and then
I believe on your announcement you mentioned that we are allowed to use notes on the exam, just not like websites
That's
or help
correct.
from other
So
people.
just
Is that
anything
correct?
that you've written down so your written notes. And let me stress this because this is really important for everybody. if you try and go back, to look at like past assignments or, even a past review like that's online and it's, on Lumen, that we do our homework in. So if you try and get into any other assignment while you're doing the test, it doesn't matter if it's on that computer or if you go in on something else, it will kick you out and you'll get a 0 on the test because it's assuming that you are trying to cheat on it by getting into other stuff. So you can use your written notes, so anything that you've written out, like the lecture notes that you've taken notes on, any of the, like weekly reviews and stuff that we do, you can use those. Okay, just not anything that's online. Does that make sense? Is that clear?
Yes, thank you.
Yeah.
Yes, thank you.
Okay,
And
good. No, those are really good questions. I'm sure other people had those same questions too to, want clarified. I'm glad you asked. Anything else just in general about the test that any of you are wondering about that I can answer for you? There's 20 questions. You have 2 hours to take it. You can use your personal notes and you can use a scientific calculator. Those are the only 2 things. Yeah.
Another question. Is this going to be like a paper exam where we upload them as PDF? Or how are we going to submit our written work to you if it is like submitted the same way our
so
homework
notice
is
that
online?
In that area where you have the test, at least for my classes, you'll see that I have a different assignment, right, where you're going to upload that work. So you'll just take pictures of your work, save it as a PDF, and then upload it to that assignment. Does that make sense? So it's not right on the test.
Yep. Okay. Perfect.
Okay, awesome. Those are good questions. If you think of any others, great. Let's look at number 20. We'll have just a few minutes to do this. This one won't take very long to go through. All right, so remember that when, for the domain is the set of all x's, right? So those are the x values. And the range are our y values. And so on this one, we just have, 5 specific points. It's not like, you have like a parabola or something like that where you have like a bunch of, gazillion points on here, right? Your correspondence is just these 5 points, okay? And so when it's asking you to find the domain and range, the domain is simply saying, what are the x values? And you want to make sure that you write these out from smallest to biggest. And, so start and see, okay, looks like the smallest x value is -5. Whoops, I wanted to do this in a different color. Some blue to correspond with that. So -5, and there's 2 -5s. I don't need to write it down twice. And then 2, and then there's 2 7s also, all right? And then my range are all my y values. So again, I'll write those down from smallest to biggest. So -11 is my smallest, right? Then -4. -4 shows up twice, but I only need to write it down once. And then 3, and then 5. Okay, and these actually go inside the little squiggly brackets, right? To be technically correct. Okay, those are inside there. All right, awesome. Yeah, you got that written there. Okay, so then, is this a function? How can you tell if it's a function or not? Okay, so Camilla's saying it's not a function because we have repeating values, right? I see that I don't, -5 is going to -11, but -5 is also going to 5, right? 7 is going to, let's do a different color. 7 is going to 3, but 7 is also going to -4. Okay, but if there's just one value that's repeated, right, then it's not a function, right? Because we can't have repeated x values. We don't care if the y values repeat. We just can't have repeated x values. Okay? And you can say, you know, because -5 and 7 are not unique. That's how we say it in math. Okay? Because they're going to two different numbers. Okay, and remember, if you're trying to look at a graph to tell if it's a function or not, you do the vertical line test. So this would be a function because it's only hitting in one place. But if I had like a sideways parabola, right, and I did the vertical line test, this would fail the vertical line test because it's hitting in two places, right? So this is a function that only hits in one place, but this is not a function because it hits in more than one place. Right? So they might ask with pictures also if something is a function or not on the test. So it's good to make sure you know that as well. Okay. All right, on those other ones that we didn't get to, I encourage you to still go through them. And then there is, you know, the key is on there as well. Were you guys able to find it on your Canvas page? If you want to leave your email address in the chat here, I am more than happy to send that to you. If you didn't, I'll send you the, you know, the practice as well as the key. All right. All right, guys, I hope you do great on the test and that everything goes well for you. I hope this was helpful for you, and I know you guys are going to do awesome, okay? So study up and then get that test taken. Okay, you're welcome, guys. Thanks for coming.